want to give an example of talking about what would a parallel series combination kind of techniques that you often hear about in circuit classes, but why does it turn out to be helpful? And at some level, what it is, it's the first of many different kinds of intuition that allow you to start changing and modifying circuits and simplifying them. And some of those simplifications can be thought of mathematically, but it can also in parallel be thought of as a graphical form of the solution. And so we want to begin to think about these different ways of looking at it. So imagine I hand you a circuit like this, and if you haven't done a lot of circuit analysis before, you're going to look at this circuit and think, wow, this is going to be a lot of equations. I have to write a different loops, and I have to see how I can make this work. And then I start to think, well, what could I do to kind of simplify it? Well, we know that, for example, there are rules of combining parallel elements. So two resistors in parallel turn out to be the parallel combination of the two. And you might remember that that's like a 1 over of those things, right? So you're like, okay, that's interesting, but it does simplify nicely. If they're both identical, then the value I get is exactly half. You might think about, I can actually go through one resistor or the other, so putting two of them in parallel means kind of half the resistance, right? Two different paths of which to flow. The other thing is if I have two capacitors, I can think about this as a case of, I get to add these two when they're in parallel. So it means now I'm going to get 2 times that capacitance. And you might think, oh, okay, how would I think of that? Well, it's like, if I think about a capacitor at a certain area, if I end up just having 2 of them, it's like the area went up by a factor of 2. Okay, so this is kind of a way you start thinking about this. And you look at the circuit down here and you think, well, that's certainly better. Still a bit to think about though. Well, the first thing is I can actually take the 2 resistors in series and they get to add. So I add those values directly. And one of the things you start to notice is that there's an interesting dualism between resistance and capacitance. And one of the things another way to think about it would be a dualism between resistance and conductance. And you'll see this as you work through other circuit elements. If you look at capacitors, you actually get 2 of them in series. But capacitors in series behave like resistors in parallel. So we're going to talk about these two elements being in parallel. So that's what I'm going to see here. Now I'm going to use this parallel operator to say I've got 2 elements in sort of a parallel operation. It's sort of the parallel operator structure. Normally I might think about it as 2 resistors, but in this case 2 capacitors that are in series act like resistors in parallel, so I'll use this operator. And so this would be the circuit I would get, but I would also need to remember one more thing, because what I'm measuring across this resistance is V1, not V. And you're like, how do I go between the two? Well, notice something you'd see here in terms of the voltage, the total voltage across here, and the voltage across this resistance. You might recognize that this is considered a voltage divider. If you don't recognize it immediately, you can actually write KCL at this node, and you can actually pick this up pretty quickly. But what it means is that this voltage will be some fraction of the total voltage across these 2 resistors. And so I'm going to keep accounting of that. I'm going to keep it off on the side here so I remember what I'm looking for in terms of my numbers. And so if you plug in some numbers, and here's some representative numbers both in kilo ohms and in microfarads, again, typically one form of a set of consistent units. So you might find that resistors, you would often say consistent units of being ohms and sort of volts and ohms and amps and farads. You would also have a different set of things where it's talk about volts and milliamps and kilo ohms and microfarads. And you'll start finding that a lot of these things give you very consistent kinds of numbers as you work through it. So that's sort of very typical thing. So pay attention to your units, because you can possibly sort of simplify things and get intuition by looking at that. These are pretty typical units for discrete parts that you might pull off the shelf in different places. So if I take these values, one of the things I can start doing is I can start plugging in. One of the things, and I start looking at the circuit, and all of a sudden now I plug in the numbers, and it's a very simple RC circuit. This is what I would have had in this case, what I would have had here, where I have a very well-known time constant, and I can build from there. And what we're going to find is over and over again is that we can kind of take these techniques and either think about them graphically or analytically to kind of take what often looks like a very complex circuit and make it into a far more simpler element to work with, and that we can actually analyze often just by looking at it and we recognize the forms.